Hi and welcome. My name is Rafael Taubinger and this is an embedded trust in-depth demonstration. I will show you in practice on how to make use of protection of provisioned data with secure enclaves. IR systems and secure Thingz provide a complete solution for the product volume curve. I will focus on the application development, and this is highlighted in the following slide. So, this mainly covers the application development with Embedded Workbench and Embedded Trust, and also the Secure Boot Manager development with Embedded Workbench and Embedded Trust. Before I actually go and do a demonstration of Embedded Trust, let me give you a brief overview of what you are going to see. In the first part of the demonstration, I'm going to show IR Embedded Workbench with the Embedded Trust tools installed. During this, I will show the creation of a simple, secure IoT example running on the LPC55S69 MCU, fitted on the LPC Espresso 55S69 EVK board, and the iJet debug probe. The steps are, first of all, I will import a simple example, Getting Started project, which will act as my main application later in the demonstration. I'll then create a Secure Boot Manager project, which will also generate our security context, which is basically the description of the security environment that is required to protect your application. And in this combination of Secure Boot Manager and the wider security context, that will provide our immutable root of trust to protect the system, and also enable the use of POP-D, the protection of provisional data via the encrypt and authenticate feature that will make use of the technology that's available on the LPC55S69 device. It's mainly the PUF, the PUF technology that comes from physical unclonable function. I will then build the SPM and provision it and the other security information needed down to the MCU, thus implementing the root of trust. Provisioning basically means that we will program it into Flash, but as part of the process we will be interrogating the MCU in order to obtain information from it that will be embedded into what we program. Then once provisioning is completed, I'll reset the board and show the status logging output over the serial port by the Secure Boot Manager as it boots. And at that point, I can now switch over to developing my application using the Getting Started application that I imported into my workspace in step 1. So, first of all, I will need to configure the Getting Started to enable it to make use of the security settings from the SPM project. I will then build and master the Getting Started, creating a software update file compatible with the provisioned SPM, and start my debug session, which will cause my software update to be programmed into Flash, so that the SPM can install it as the MCU resets. And finally, once the debug session is running, I will then be able to interact with the Getting Started application and make some calls into the SPM Secure API functions. So, let's move to the practical part. I have here IR Embedded Workbench for ARM open, and Embedded Trust has been installed to work alongside the IDE. So first step, as I said, I will mainly make sure to open my application. It's included here in the information center, and we are going to use the LPC55S69. I will just make sure that I create a new folder here. I'm demonstrating Embedded Trust, so let's call it demo ET. And from here I can just proceed because it's copying the Getting Started application. And since I'm using the board here, I will make it easy and use the right example that is provided. It also selects the iJet that I'm going to use to do the programming. So what we need to do here is of course later make sure that we add some additional settings and we download the encrypted image of the application to the target. But before we start on that, I'm going to create a new secure boot manager. That's essential here. So I will just create a folder here, call it SBM, on the same root as we had our application. You could copy it anywhere, but it's just for convenience here. So as you can see in the README file, there are some instructions like selecting a device, creating a security context, and selecting the right debug probe. So I will just start by doing that. First step is to make sure I select the right device that I have here on my board. So I can start here with selecting the device, as I said. We are using the NXP LPC 55 S69 core 0. So that's the first step. And here, as you can see, there is a menu here related to security, and we can enable security here. I will create a new security context that will mainly combine all the security configuration here. I will do it with identity, production control, and IP protection. And the next step is, of course, we need to define some names here that we can decide by ourselves. My context, probably should just make it look better here. I need to find a place to save it here also. So let's save it inside the same folder. And finally, it's asking about the organization. I can just write here IR systems. Organization, I will put it R&D. Country, we are located in Sweden here, but the Secure Thingz is located in UK, in Cambridge. We work together. It's we both are part of the IR systems group. Location, it's Uppsala, and the same for region here. So of course this is just for convenience here. Well, as you can see, you can even select the number of certificates, or if you are going to read out the device ID or use a random number. Of course, from a device it's way more important here. So I can click next, and for the update mechanism we are using here full encryption, and of course that's the best. So I will create the security context here, and it will be already selected here. But before I complete it here, there are a few things that we should take care. First of all, we actually want to use the capability here of protecting provisioned data, and that's part of the MCU. I will talk a bit more about that. So what mainly happens is that, of course, embedded trust is designed to help to achieve full compliance across the best practices, and protection of provisioned data is actually critical in meeting compliance with security standards, including here the security storage of credentials. So the standards, of course, require protection of provisioned information. So to mention a few of them, of course, the European one, EN 303645, but also the others like the NIST IR 8259, ISO 24702, IEC 62443. They all, of course, require this. And with embedded trust, enabling this capability, and that's, of course, also part of what the NXP device can provide. So NXP is implemented with the PUF, the physical unclonable function, to of course make use of this capability. And mainly what happens is that it's available on the LPC 55 families, and the physical unclonable function PUF uses unique device SRAM characteristics to scramble secret key data so that there is no way to recreate or recover the secrets. So in order to make use of it, I mainly need to enable here the encrypt and authenticate. Very easy and straightforward. So once this is selected, I can confirm here. But maybe since we are already here in the settings, we want to have the best size for the secure boot manager. So I will probably just make sure that we create the smallest possible application here for the SBM. And finally, we want to connect to the target, so we need to select the iJet as debugging probe. Of course, the LPC55 has the Trustone capability, so we want to enable that. That's of course the best here, because we can enable the secure mode, and from here I should be fine. I can just confirm this. You will see that the project will be populated with all the source code, and I should be able to do a clean build here on my project now. So we can just wait a few seconds. This should be pretty straightforward on the build process. And what will happen is actually from this point we will be able to do what we call the provisioning. Where the secure boot manager plus secrets will be programmed into the device, and I will do that now. It's a few steps. It will connect to the device, read the device information, and do the programming. And this should just take a few seconds and should be completed. There's also some information in the debug log window that you can have a look quickly. So, and the most important part here is actually that we can see here that the provision data is protected using encrypt and authenticate. Perfect. So from here, I can now move to my application, that it's the getting started. And once I open here the project, what we need to do is to make sure that we are selecting the same, exactly same security context. Because this application needs to be encrypted, and that process of encrypting the application is named mastering. We will see at the end of the build step that will happen, and it's straightforward here because I just need to enable security here. It's on the menu. Maybe you also missed it, but it's also on the IDE menu here, so that's the way that you know that you have access to the security tools. And once I select here my context, we will see that we also need to enter some additional information, and that's actually the version. So we'll see, we can maybe start with version 1 here. Probably it's the best what I can do here. It's our first one, so I confirm it here and do a build of this application, and we will see that step that I just mentioned about encrypting the application. That happens at the end. It should be straightforward. And to make you aware, since it's an encrypted application, the only entity that will be able to open it up, it's of course the secure boot manager. That's why it needs to be the same security context that we are using here. So as you can see, the mastering step was completed, and we have our output here encrypted. So from here, before I connect to the target, I should probably open any terminal utility. I'm using PuTTY here, but of course you could use anything else. And I will download this encrypted application, and what will happen is that the secure boot manager, of course there will be a reset, secure boot manager will jump in, will of course try to open up the application, program it to the right slot. So that takes a few seconds or milliseconds, but it's straightforward. And we will see that some information already appear here from the secure boot manager, and the most important one, it's already there. So if I just scroll up here, we will see that the provision data encrypted is confirmed here as set to 1. There is some other logging available here, but that's the main part I wanted to make sure that we see here. And if I leave this application running here, we will of course be able to interact with the application. So I can just press, for example, help here, so we'll see what's available, and then I can run, for example, a device test, and we will see here the result. It's interacting with the secure API, and device ID from hardware, it's being displayed, result pass. So, and the device ID was found in the device certificate. So that's the process when we read out information, included it, and we download or we do the provisioning of the secure boot manager with all the secrets at home. So good. And from here we would be able to do the export. So that's mainly what we do. There is a security menu available for the SBM, and I can just quickly show you how it looks like. So the feature I'm willing to mention here is actually the export direct through production, and from here we would be ready to move to desktop provisioning, initial manufacturing, or even volume production. So there is a dedicated demo for the secure desktop provisioner, so make sure to check it out too, yeah? And finally, I would like to thank you for your attention, and I hope you enjoyed this demonstration. If you have any questions, please reach out to fai@ir.com. Thank you.